this is our subject, the Spertus building, which then relates to the avenue. And one of the things is there's a lot of glass here, so the building thinks about using glass. And as you move north, if you turn the other way and look north along the avenue, you begin to see that the surface of the buildings is punctuated. Here in Sullivan's building, there's a plane that defines the outer edge of the building, and then he carves very carefully away back into the wall to reveal the windows. And farther down the street, you can see, for instance, here, a wall in which bay windows project from the plane of the avenue in this rippling kind of way that I also talked about yesterday. So there is a real character to the city and the buildings around it. And here, again, just to keep you oriented, this is the park, the Grant Park that we talked about yesterday. This large object is the Art Institute. Here's the fountain that we looked at. This is where the Gehry and the Plensa and the Kapur are located. This is the site of, let's see, right here is the site of the Spertus, sorry, right here is the site of the Spertus building that we'll be talking about. Jeannie Gang's Aqua Tower is on this site. The Lake Point Tower that I talk about a little later is on this site. And as I mentioned yesterday, the site that Jeannie is thinking of asking you to consider when she comes here in April is this site. So I thought that by looking at 1, 2, 3 completed buildings, you'll then have a better idea of what the environment is, both the near environment and the regional environment in Chicago. And now I wanted to take a look at the individual sites of each of those 3 buildings. So this is Lake Point Tower. And what you see here are a series of drawings indicating where the shoreline was of Lake Michigan. And this is the plan that you're looking at is a plan from about 1870, about 100 years before Lake Point Tower. The original shoreline of the lake was here, and then people in Chicago started to fill the land in so they could make slips for ships that were coming and going. They began to extend the shore here. In 1870, the site of Lake Point Tower was in 18 feet of water. Right? So after the fire, all of the debris from the fire gets trucked over to the lake. All of the sand from the foundation of all of the houses that are being built in Chicago is trucked to the lake and dumped into the lake to extend the shoreline. It's always a good idea if you can make new land. It's a very healthy one. And so by the time, and so the dark lines that you see here are the lines of current, of present day structure of the present day lakefront. So you can see that it's been extended very much farther out than is the site here. But this is part of the background of Chicago. Next, I want to show you what has become of this site, because here is the same curve that you see here is the shoreline. That's this curve that you see here. So this is now the site here of Jeannie Gang's Aqua Tower. Here's the little park that is part of this large development that's here. And so and here is that line of the shoreline. So you can see that Jeannie as well is occupying land that is made land, that's new as the city has extended into the lake. And you can see that in the plan too, she includes the Gehry bandshell, a bridge that looks like a snake that Gehry also designed. And here's the Kapur sculpture, and here's the Plensa fountain. And all of this is the north end of Grant Park. And now the third site plan is the site plan of the south end of Grant Park. This is part of the Art Institute. And so just about here, if you went farther north, is the south end of the plan I just showed you of Jeannie's work. So you've got this sequence down the lakefront. So all 3 of these buildings have a profound relationship to the water. And here is now the site of the Spertus Museum. And as part of the situation, here is that rail line that I showed you running underneath the Art Institute yesterday. That continues as a rail line in a ditch, in a submerged path, from north to south through the park. And then there is one scale of park space here, and then a much larger scale of park space here on either side of the railroad. So to go back to where we started, to now talk about the Spertus Museum itself and its relationship to the street beyond it, or around it. Coming up. So here you can see the kinds of developments of the individual buildings along Michigan Avenue, and some of them have rippling bays, some of them have well-defined entrances. This is Sullivan's Auditorium building. This is one of the athletic clubs on the avenue. Here's a hotel along the avenue, right? So there are many different types, but there are certain things, material, color, geometric, almost prismatic form that is also in play. And so the architects began, as architects do, they made a sketch, they made a model, right? And from the beginning, they were concerned about how they made the facade as something that related to the rest of the avenue, but also understood the facade as a series of what? Folded planes. That's the initial insight, and then this is an insight that then is pursued as they move ahead. So the planes get a little more, then start to get worked out. You see people fiddling with them over time. And so it begins to develop how you think about the plane, how you fold planes, how you understand that the plane, which is going to be glass, set into a light metal structure, the planes of the glass set into a light metal frame, read as prismatic, read as planar. One of the things they were trying to avoid was having the glass read as a volume. They wanted to read it as a series of planes rather than volumes. So this is one of the ideas that they're trying to work with. And as these elements develop, this is that earliest piece, and now here it is at almost the final stage. But you can see here with a little bit of tape up here, they're always willing to reconsider. They think they have it solved when they go home one night, and the next morning they come into the office and someone says, it's not quite right. And while the two principals of the office, Ron Krueck and Mark Sexton, and Mark was here 2-3 years ago when this course was last taught, the two principals are the major design factor elements in the office, but there are several other people in the office who are also involved in those design issues. And so that collaborative quality of the practice is important to understand. And so as they begin to get to the presentation of renderings of what the building will be like to convince the client and to convince the public that this will be an effective building, they then come up with these two images. One seen in the daytime where this plane treats the light in one way, this plane treats it in another way, this one treats it in a third way. So that idea of planes in light moving, and because throughout the day the sun is moving, throughout the year the sun is moving in the sky. So the way that the facade reads changes all the time. And here they now want to show what happens when the building is illuminated at night from within. So it becomes something that glows. It becomes overall a single volume, but the single volume is made up of many different parts. So it's possible to see the elements, it's possible to see the whole, it's possible to connect to the way the elements and the whole relate to one another. Well, before I start talking about the plan, there's one other thing I think that is important to mention about this idea about the relationship of the sun to the building. You live in a place that's very close to the equator. When it's noon, the sun is almost directly overhead in February, And in August, the sun will still be pretty much directly overhead. The sun rises in the morning, almost always at around the same time, and it sets in the evening, almost always at the same time, and it rises from the same place. Farther away from the equators, well away from the tropics, the sun's angle above you changes dramatically. In the winter, it's as low as 22 in Chicago. It's as low as only 20 degrees above the horizon. And in the summer, it's as high as about 65 degrees above the horizon. So it never is as high as it is here. And so as it moves on the horizon, that changes. And where the sun rises and sets changes. In the summer, the sun rises about 40 degrees north of east. In the winter, the sun rises and sets about 40 degrees south of east. So that array of qualities of light on this building in Chicago creates, in summer, in winter, very different effects because the sun is in a different place in the sky. So this is also something that's important to understand about where you are. Some of these issues may never come up in things that you're thinking about. It's a very important issue for an architect designing in a city like Chicago. Okay. Now, the building is, unlike most new buildings, well, that's right. Most new buildings, even in Chicago, are now, tall buildings, are reinforced concrete. That's basically the standard. But there are still many cases in which steel is a more attractive material to use. And in this case, we're looking at a steel building, a steel-framed building, most of whose structure is at the perimeter because they wanted to have as open interior spaces as open as possible, so that the floors through the building are pretty long spans. And as you can see here, and so the regular structure along the perimeter you can read here. But they've then designed the structure in such a way that usually a building of this type, which we talked about yesterday, is a frame of this character. The columns are regular, the floor plates are regular. But if you are thoughtful in your design, you can place a large theater space in the building here, then exploit this as a large atrium space, have other atriums open up here and other places in the building. So this is a building which simultaneously, just as the facade is trying to be important in the day and at night, the structure is trying to be simultaneously regular and predictable, but also give permission for the building to be sectionally very interesting. And they're also, let me just show you this quickly and then I'll go back. So ground floor, second floor, third floor, 8th floor, 9th floor, 10th floor, the plans are all different, right? And what the architects are trying to do here is have two important qualities of architecture. One is the idea of the free section, which is usually thought of as being something of architecture before modern materials, that when the free section of a building that has a large central space or something, that's one thing. And modern architecture then gives up the free section for the free plan, right? I mean, Le Corbusier taught us about the free plan. It means his sections are fairly regular, but the plan is is much more fluid. Well, what Krueck and Sexton are thinking about is because we're familiar with, we're confident in using materials in particular ways, we're now in a position to include both a free section in the building, as we were looking here, or elements of free section, and also a free plan within the building because we're in control of our materials. And so there, as you can see, they need to service the building at the back, they need to sell products, they need to have a large lobby where people can gather. Security, the Spertus Museum is an institution of members, principally members of the Jewish faith. There is a rabbinical school here, there is a library here, there is the museum, there are public programs. But as in most of the world, members of the Jewish faith live in a world that is under stress, shall we say. from various kinds of threats. And so the security, although the desire is to make the building as open and accessible as possible, they also have to be well aware of security for the building as well. And so as you move from the bottom to the top, there are routinely large open spaces that you can see that you move from one zone to another, as well as a series of smaller spaces. And you've already figured out that all sorts of subsidiary elements, the kind of elements that are tucked into the poche of a traditional building, are now treated as a zone along this side of the building. So elevators, toilets, storerooms, kitchens, the refrigerator, all of those kinds of things that are necessary for a building can then be organized in a uniform way on one side or the other. And as we continue to move up through the building, you can see how in some cases the structure becomes almost completely regular, except something is missing here and here. Up here, then lots is missing, or seems to be. So this is another example of how the architects are able to exploit what they're working with. And also, I think you can see the plan expression of that folded plane of the facade keeps working from bottom to top as well. And so here, I think I've got 2 or 3 images showing the way the light hits the facade at different times of year. So this is clearly in the summer when the trees are out. Here are 2 images on the left in the summer. Actually, this is almost the same time, taken from the north or from the northeast. The facade reads in one way. Taken from the southeast, the facade reads in a different way. So that aspect, so it's constantly changing even as you move around the building. Or here, 2 other images, fairly early in the day on the left and in the winter at night. And the light, which is warm and golden largely here, becomes very cool and silvery here. It's the same element, but the elements of the building take the light constantly in different ways. And as you line the building up along Michigan Avenue and recognize the texture of the street facade, the recession, the recession here of Sullivan's buildings, and then the projections here, then the building begins to both be part of the avenue, it respects the street line, it respects the massing, and also becomes distinctive. We know this building could only have been built about this time, whereas these buildings could only have been built, in this case, 125 years ago, right, in their time. And so we have this unified urban expression in Chicago whose individual elements have been constructed over a series now of about 125 years. The auditorium building, completed in 1889, was the first building of the present scale of Michigan Avenue. So as I say, that's exactly 125 years, right? That the avenue has been being built in this manner. And in the Burnham plan of Chicago, this building is actually shown as an element. Burnham's plan recognizes that this is the kind of scale to which we wish to build the city. And then, Sullivan is long dead, Burnham is long dead, but to be patient, to have a really good idea, a strong idea, and be patient to let that idea survive over time, and trust that the architect who builds this building later, who builds this building later, who builds this building later, who builds this building much later, will respect the idea that has been established. This then creates this sense of Chicago as a distinct place, as a place in which architecture coheres, rather than one in which architect is disjointed, one element from the other. And if you get close up to the building, you can begin to see vague kinds of ideas. You can now start to see the clouds and the blue sky in one case. In other cases, you start to pick up something as precise and detailed as the tree just across the street. And so if you look up at the facade, so that as your point of view changes, the experience of the building changes. And as you start to approach the building or start to come into the building, there's even a way in which by folding the wall out, it begins to say, come on in. Come on inside. It's open. The building is open. Please come in. And once you get inside, you then are connected directly back to the outside where you came from in the first place. By making the wall a glass wall, and again, as you, I'm sure, understood, the very back of the building is the alley, which is service, so that's opaque. The side walls of the building are medianeras, is your word, or the Spanish word? It's a party wall, so that's opaque and solid, right? So only the one side of the building is transparent and open. And so this, too, is something that they said, well, this we have to concentrate on, right? These elements here on the sides, we know how to solve that. It's solved well. But this is where the building truly has its effect. And that ability to, as you recall yesterday, I mentioned that one of the ideas in Chicago buildings, of the early buildings, was to admit as much natural light deep into the interior as possible. Well, that's still an idea that's in play here. And as you start to move around the building, here at the ground floor, here from farther up in the building, the layering of the building, the layering horizontally, the layering vertically, the presence of the angle that's an artifact of the photograph, or of the flights of stairs, a landing that seems to float, all of these then make the solid parts of the building seem to float just as much as the ethereal, the transparent parts of the building. And as you then continue to move around, the presence of individuals reflected in as shadows or reflections in the glass as they move around the building also has an impact. And this continues as you see people moving up and through and around the building. It becomes this constant quality of movement and expression and visualization. Right? One is always visually connected to other aspects of the building. And as you continue to move up and through the building, you can see that as well. And the architects then give you lots of opportunity to see how carefully detailed all of the elements are, right? So that everything works, everything is consequential, everything is easy to understand. And as you get to the top of the building, this is a photograph from the construction, you can see how they had to move in this scissors jack to let people in. But here's the point of the building, to relate to the park, to have people be in the building and use it, but then to give them access to the park and then the Great Lake and sky beyond. And so here then we've got the Spertus Museum in Chicago. We're familiar with Chicago from the lakefront. It's a place, it has real character. And as you can see, the opportunity to build a very tall building is something that is exciting. It gives the city character. And so a few years ago, Jeannie Yang, who at the time was a very well-regarded teacher. She teaches at my school, and she's an excellent teacher. She's a very smart exhibition designer. She had been to Sao Paulo and seen Lino Bobardi's museum exhibition panels of the heavy concrete and the plane of glass. And so she introduced that to Crown Hall as an exhibition design. She began to do some small buildings. I showed you one yesterday, the Starlight Theater with the stars on the exterior. She began to do relatively small projects. And then she had the enormous good fortune, this is the only way to say it, of being with someone who was a developer, wanted to build had the resources, had the site, and wanted to build a building that was not ordinary but special. And there was at the outset an informal conversation that then very, very quickly grew into a serious commission to do a very tall building. Now, as I say, at this time, Jeannie had worked on some large buildings when she worked in other offices, but she had never done a building of this height, of this cost, of this complication in many ways, nor had she had a building in this prominent a site. This is a very prominent site in a very prominent city. So all of these things were new opportunities. And one of the things that is always satisfying to people in Chicago, I think anyone who cares about architecture, is to see someone who is given an opportunity, then grasp the opportunity and do very well with it. And this building, I think, demonstrates that. It demonstrates that it is possible to be still fairly young and be at the early stages of one's career and both be given an opportunity and be able to respond to and realize that opportunity. And as Jeannie began to develop the project, she remembered, she knew that in Chicago, we have created our own mountains, right? You and people elsewhere in the world have mountain ranges. You've got a perimeter of Sao Paulo of fairly tall mountains that you can see. You are at, what, about 700 meters, 750 meters? So you're well above. Chicago is at about 200 meters, right, in this very flat plain, so above sea level. So our relationship is different to the land around us. And so instead of having a mountain range, we have constructed a mountain range. And so every time an architect gets to do a tall building, it's to add to this kind of what becomes a natural kind of event. And the building on the left, as you see completed, is an extraordinary object. It's a rippling form that rises into the sky. And on the right, under construction, it presents this idea that tall buildings are reaching for the sky. They call them skyscrapers. They call them cloud scrapers. They go into the sky. And of course, it has the experience of disappearing. Some days when the clouds are very low in Chicago or there is fog, then all the great buildings disappear, and that's also something that's very exciting. Here is that plan that we looked at before, and let me talk to you again. Here is the site, and this whole section here is principally of high-rise apartment buildings. These are some older buildings here. This is actually an office building. This is an apartment building that was going up just a little bit before this building. This overall site plan shows many different buildings proposed on the site, but it's this quadrant that still has a few holes in it. It's in this quadrant, I believe, that Jeannie is going to then suggest to you. This is the site that you will have. There is also the fact that as you can see here, the bridge roadway runs beneath this level of roads. Along the Chicago River, especially along this side of the river, the right bank, there is a double-level roadway that goes back to the Burnham plan. The lower level is for commercial traffic. You can bring projects to buildings and unload, and they can go into the building. And the upper level is for personal traffic, automobiles and bicycles. And so the multiple roadways mean that even though this is a lakefront site, the site itself has many different levels. So the building is entered on this level, but the level down here is well below even the level of this roadway, because you can see there's a roadway up here, there's a bridge running underneath this roadway, and then there's a lakefront level that's even lower than that. So the site of this park is about 30 feet below the site of this street. So that means that the bottom of the building is very deep. There's plenty of room to place the parking garage, which if you can, you place underground. There's plenty of room to place stores and shops, because on the side of the building that faces the park, they're above ground. They're below street level here, but above ground level over on this side. So this also becomes an opportunity for the development of the building. There also, as these view lines are shown on the plan, there's also a concern for what you could see from the building. What are things that are important to see? So the lake itself, Navy Pier, which is what this overall area is called up here. The rest of the this lakefront community is here. The shoreline of the lake, which you can see down here, and also you can see it up in this direction as well. The bridge, the nearby bridge, just over here, and the cloud gate sculptures, that 1 and 2, all of these are within view of the building. So one of the things that was recognized early on is, even though the building is in a cluster of other buildings, it doesn't have a free view in every direction. But where it does have a view, the idea was, let's exploit where we have a view. So that is where the idea of the undulating floor plate begins to emerge. I mean, we just saw here the floor plates undulate, and they undulate because here there is a good view in a particular direction. Here the view is not so good on this floor at this height. So this is where this concept begins to emerge. And here you can see that from the band pavilion, there is a clear view of the building, which means that everyone in the building has a good view in this direction. Here from the Art Institute, this is the Art Institute building, and this is a small park by the landscape architect Dan Kiley. There's another good view of the building, which means that the buildings and its occupants, at least from about this floor and above, have a good view of this area, of this part of the city, of this open space. And the building itself creates, I have to admit, Jeannie was in Sao Paulo before she built this building. She'd been in Copan before she built this building. And when someone pointed out to Mies once that he was using a detail that was used by Carl Friedrich Schinkel, as if I've caught you, you've made a mistake, you're using somebody else's idea, Mies's response, and I think it's the perfect response, was, it's still a good idea, isn't it? And if it's a good idea, it's still in play. So whether this is from Copan, there's a Chicago architect named Herman Schwartz who also was interested in the idea of extending the floor plate of a concrete frame building away to create a brise-soleil, which is the principal idea of these extensions. So she would never claim that she's inventing this concept. She is willing to claim that this is an opportunity where this particular concept makes sense, right? You don't run it out every time you make a building, but here you have an opportunity to make a building and use this device. And also, let's be very clear. It looks terrific. I mean, this is an exciting building. Inside are apartments for people like you and me. Maybe they have a little more money, right? The apartments are going to be fairly ordinary, right? This is in many ways a sort of dumb building, right? Apartment buildings are often not very interesting because they're not very challenging. You're just repeating how many 3-bedroom apartments do you want, or how can we work in the studio apartments and the 3-bedroom apartments, right? Well, here there's a thinking that that's present, and if you rationalize the planning of the building, you then have resources that are available for the construction of the building that can be used for some other purpose. And so here, this is what begins to occur. There's another savings that using this seemingly very expensive structural device, the projection of the floor planes. It means that every window wall, all of the enclosure for the apartments, is a very cheap system. In Chicago, we call this a storefront system. It's not a curtain wall. If any of you have worked with curtain walls for tall buildings, you know that a curtain wall, well done, like we just saw at the Spertus, a curtain wall is actually a pretty expensive project. And so by being able to use shop front glazing systems, you have the workmen who install it have much less, there's less skill involved in what they're doing. They're doing something simple and repetitive over and over again. It's not complicated. So this also makes the building, is an efficiency of the building that recovers or doesn't spend money unnecessarily. And as the building is completed, you can see, again on the left, another view of that rippling quality, or here from up in the building, a view down over. Actually, I happen to know, all of these characters are not occupants of the building. These are members of Jeannie's office staff, and they wanted to take the photograph and said, okay, now we'll put you all out on the balconies so it can look like the building is complete. But in any case, you can see how these floor plates change, and how for this person, the view out through the slot between these buildings is going to be important. The view out in this direction is important, and you can see the relationship it has to that large interior park that I showed you early on when we looked at the site plan. And so this quality of the building as an object that is interesting in the skyline, that's a good thing. The building as providing a place from which to contemplate the attractiveness of the rest of the skyline is also present, right? And that reciprocity, I talked before about transparency and reflectivity, this reciprocity of view, the view of the public of the building is satisfying, the view of the city by the occupants of the building is also satisfying, and this is another way in which I think this building achieves its success. Now, all of that quality didn't just happen. I mean, these concepts may have been identified fairly early on. If we use shop fronts for enclosures, we can have a saving that way. If we develop a system of pouring the concrete floor slabs, we can make that efficient too. We have computers that allow us to make shop drawings so that the concrete contractor, when they get the drawing, says, oh, well, that's not going to be so hard. I can do that, right? So all of these things are taking advantage of technologies that are recent and also being able to work with them. But the work in the shop begins with a model of the area, a model of the building, a model of the areas that you want to be looking at, and then pieces of string tied between, this is Jeannie, by the way, pieces of string tied to what you want people to be able to see. So there's this direct engagement with the building, this direct engagement with the model, this regard for the building. And here you can see that this is a very early stage in the development of the process. The building is seen as a kind of topographic surface in which the various, usually when you do a site plan, you'll do layers indicating the elevation intervals of the topography. Well, they're starting to think about, variation in the horizontal plane. Well, can't we think about variation in the vertical plane? And so that too is part of this initial insight in the development of the building, as one then sort of has an insight and then says, well, okay, we've got an insight. Will this work? Is this just an insight that doesn't work here? Will it work at all is a question that's important. Will it work here is also a question that's important. And so they began to do modeling early on when Jeannie started teaching. So this is something that in which your preparation for the future is sometimes you're not aware that you're preparing yourself for some future product. One of the things that Jeannie has always been interested in is the natural world, and she's been interested in birds and birds in flight. So when she started teaching at IIT, she talked to the people in the engineering department who had a wind tunnel. Well, they were interested in the wind tunnel to test certain objects and materials in certain ways. She was interested in modeling buildings and then watching the way wind moved around a building and what its impact would be on birds that travel through Chicago on their migratory paths. How does this work? So she's beginning to work on this. And so what this drawing is then trying to represent is not only I'm sure you've read this as a kind of a layered plan of these are the projections of the floors, but also thinking what those lines of force, what the wind's lines of force will be as it moves around the building. Because also, in addition to not wanting to hurt the birds, right, if she designs the building in such a way that the birds don't always fly into the glass, then the building is successful. That's one thing. But also, is this a way in which as the wind moves around the building, she can, as I mentioned yesterday, our structural engineers now talk about confusing the wind, breaking it up. And so this is a way of exploring that. And then that concept then is realized as you see the building here under construction, and these devices, these elements that the contractor has brought into play as you see the building under construction in the winter. I mean, this is snow on the ground nearby. So if we look at the building simply as a section through the tower, we can see the roadway that I mentioned before. Then here's that roadway level of the bridge that I showed you. And then here's that bottom roadway level. So there's 3 levels of vehicular circulation that's available. And that means that you can have the entrance to the garage not on the principal street roadway, but down here or even down here. You've got parking down in this zone. You've got shops and stores in this zone. As the building has further developed, the lower floors of the building have been developed as a hotel, and the upper levels of the building have been developed as apartments. And so this is, I don't know if this is the routine, this occurs in Sao Paulo, but in Chicago, the exact mix of a building will vary over the actual construction. An apartment building needs water and sewer and electric and telephone and all of that. Well, a hotel needs it too. And so it's not at all unusual for usually for the hotel to be in the lower zone and the apartments to be in the upper zone. Very occasionally, the prestige of a hotel at the very top of a building offering really spectacular views is worth it, and that will be developed. But more often, at least in Chicago, the hotel is put in the lower levels than above. It also has to do with elevatoring. Hotels need more elevators per population than apartment buildings. So you can have more elevators down here, and as you drop off elevator cores, as you move up in the building, and here's one indication of where the elevator cores drop off, right? So that the floor plates here, from here up, become that much bigger. The apartment sizes become regularly a little bit bigger. So again, we're talking about knowing how all these elements go together and then being confident in exploiting the benefits that accrue in one way or another. So this is Practical Apartment Building 101. And this is how do we make a practical apartment building also visually exciting. We can call it a wave, we can call it a swell, we can call it a cleft, we can call it a flare. These are multiple English words for the kind of rippling surface that is present. But this is a way then of thinking about a kind of concept that you have in mind that you would like to achieve, and also being able to achieve it in the inside of the building. Because all of this flashy stuff is just is a very thin layer on the exterior, and then all of this is something that is quite repetitive, quite ordinary, quite easily enough solved that even people who are not as good architects as we would like can be successful, can have work and get it achieved. Another way that they began to think about the building was in terms of pools of light and air. Again, the idea of a topographic map, which these drawings are placed against, is one of the things that they're thinking about, and then looking at it in terms of different ways of realizing the building. And by exploring the building in different ways of representation, it also presents an ability to test the strength of an idea. Another one of my colleagues at IIT said when he actually did 2 theses for Mies van der Rohe when he was in school as a graduate student. He did one in which he explored the ideas of Frank Lloyd Wright in using wood, and then he tried to explore the ideas of Mies van der Rohe, but using concrete. Because he knew that Mies's work already worked in steel, and he wanted to know how strong Mies's idea was. If Mies's ideas would also translate into concrete, a substantially different material, then that meant Mies's idea was an even stronger idea than if it only worked in one application. And so that's something similar to that is happening here, where several different ideas, and so here they're called contours, terraces, pools, columns, and combined, right? So if you abstract each element out, and then you combine all of them together, that's another way of seeing how these elements work together. And here's a study of the vernal equinox, which for us, the sun rises exactly in the east and it sets exactly in the west. I mean, it stopped that long, move from the south to exactly east and west, and is now moving north. So this again is a way of understanding where the building is and how it relates to its surroundings. I expect you don't make solar diagrams here. They're irrelevant to the work that you do. But in Chicago, solar diagrams, which are made by all students, usually in first or second year in architecture school, are a very important idea to understand. And now you can see, let's just go back. So here's this abstracted studying in the office, kneeling on the table with the model and all of that. And then it begins to be realized as an actual building. Still under construction, as you can see here, and then completed, as you can see here. And I have to tell you that this is the way the concrete looks when they've just taken the formwork away, and then they clean it and paint it. And when the concrete is painted, let's see, the place where you would see this most would be at Brasilia, but I think also in the Serpentine canopy in Ibirapuera Park, the Niemeyer canopy, when the sun hits the ground and then bounces off the underside of the canopy, it's a very lovely thing. And here too, and I'm describing this because I don't have a good photograph, here too, when the sun hits the top surface of one of these projections, it then reflects off the bottom surface of the element above it in a very powerful way. It's different than the sun playing along the surface of the Spertus Museum, but it's an understanding of the behavior of the sun and exploiting it in a different way in this building. What Jeannie is trying to show here, and as you probably figured out, a number of these images I'm showing you are from publications that have come from Jeannie's office. What she's trying to show here is then the kind of final realization of the views from the building. This is inside Kapoor's beam, the Cloud Gate sculpture. This is the top of a building not far away that can be seen from the building. This is a more general view seen from up on the building. So there's a real awareness of, now it's been completed, what do those lines of sight permit us to see? It was an idea in the design. We were drawing these lines on plans and in the models. But then the real payoff, the realization, is in the actual image itself. So we've already talked about the rippling quality of the exterior, then this kind of ordinary part of what's at the base, and it's dropping down to the park below. Again, this kind of sectional excitation is important. But then you can see here that within the undulation of the exterior, the building is a fairly simple and regular box, right? And that willingness to say, it's a dumb building, it's an ordinary building, it's a regular building, now we can say, okay, we work with that, and then we have these other elements as well. And that understanding of the box then gets expressed in the way wind is understood to move around the building as it moves, and then also from the 6th, that's just the floor level down here, to the 75th. The total height of the building is 84 stories. So thinking about the building, within is that regular kind of grid in Chicago that I talked about yesterday. The presence of the grid is very powerful. It's a second nature to people. And then there's the exploitation of the surface of the grid, whether it's seen here in plan or seen here in drawings of the elevation. Jeannie's office does not have a significant engineering section or capability. She almost, for all projects, she uses a variety of consulting engineers. And in this case, the engineers were Ram Klemenchik, who is a very well-regarded North American structural engineer. And so here you see a discussion of that. And now there's an exploration of, well, what about density? This is a very tall building. That means you've got very high density. If you calculated the number of people in the building, the density of people per acre, say the 1 acre on which the building sits, that's a very high density. And there are many different ways that you can express density. And so there's the fact that her building would, if it were a typical American suburban development, would take up that kind of space. Right? That the human density here would require these many individual freestanding houses in a typical American suburban development. Or that's to say, the total area of this building is 1/7, that's to say 84 times the floor space. It's not just one, it's 84 times. But the total area of this building is only 1/7 of the area that this. So the occupation of the land is significantly less than before. And here she's trying to explore the neighborhood densities of the region around it. And she's thinking about living and working close to what's around you. And the scale moves away as you move farther away. She calculated what a 10-minute drive is. She calculated job densities from the Department of Commerce. She looked at walking distances from the building. So she's exploring density in a number of ways, not just the concentration of people in a single building, but in many other ways as well. And I think that what's important here is the building design could have been done independently of this analysis. This is a kind of analysis that you use as a check or a demonstration that the insight that you had going in, this demonstrates the qualities, the benefits of density. That's an insight that's kind of a given. You just assume that. But nonetheless, it's always useful to then demonstrate it as well, to say, okay, what does it do in terms of walking time? What does it do in terms of driving time? Where is the density of jobs in the Chicago region? And the darker color is the higher density of jobs. What's going on? What are the opportunities for doing different kinds of things, living, working, playing within? This is that 10-minute walk, the 5, 10, 15, and 20-minute walks away from the center. And one of the demonstrations here is there's a lot to do in a very short distance, that all of which could be done as a pedestrian rather than needing to get into a car. And that also becomes an argument. If there are all of these people living close to the building, it becomes an argument that the people, they want to rent the shop space, the department, the grocery store, the dry cleaners, the people they want to rent that space are going to learn very early on, there is a large population that will demand your services. So this is a good place in which to begin a business, which I think also is a very smart and important idea to pursue. But having said all that, another thing, throughout you'll hear me tell stories about Mies. One of the distinction Mies made is that in architecture there are good reasons and there are real reasons. And that is to say, and some people when they hear that think, well, that's two kinds of architecture. That's real architecture and good architecture, and they're split. Mies thought of it as cumulative, that he began with an idea of a building. I mean, this is the idea of the building that Jeannie began with, right? This is the real reason, a building with this kind of character. But the more good reasons, renting the shops, accessibility to jobs and other things, the more good reasons that you can pile together to support the real reason, the stronger the building becomes. Right? It means that you're not just acting on an insight alone. You may build from the insight, but then you're reinforcing it again and again and again with more and more and more ways in which this building becomes effective and is able to achieve its goal as a significant work of architecture and a place in which the residents and business people associated with the building say, hey, this is very successful. I heard the architect was a woman. I don't know what her name is. I can't remember. Right? Most people don't care about the architect. They don't much care about architecture. But they will know that they happen to be in a place that has thought about them, right, in ways that they might never do about the architect. And so here you can see the detail I want to show you is here. These are guys who are installing storefront enclosures for the building. That is to say, a very, very simple system. All of the elements are light. They can come up in the elevator. The men can handle them easily. They don't need cranes. They don't need complicated equipment. And they can put together the building easily. And so at the same time, the enclosure is being done here. The people pouring the concrete are working here, or they're now in a position to start taking the shuttering away. And you can see here that they're pouring the next slab up above, right? So that sequence of building, that understanding that the more you're able to rationalize the building and have, as the concrete sets down below, you can then start putting in, as you can see here, the ventilation equipment, and then put in the storefronts, the enclosure. All of that makes the building more completed more quickly. And here you've got another view of that, looking it up. All of these lines of the storefront, right, here over and over and over again. They're not here yet, right? They're still waiting for the concrete to cure a little bit more. Here's the shuttering for the most recent pour. And you can see that the shuttering itself is regular, so that means that a regular repetitive system of construction is able to yield, if understood properly, if understood well, is able to use an irregular, non-repetitive solution for this element of the building. And as that begins to move in place, you can even see here, and this is why I have the image, the residential buildings in Chicago and in most of America are required to have movable windows. You have to be able to open the window to get fresh air. Office buildings in most of America do not require that. And so we're talking about a residential building that is at the scale of an office building, but it has to also permit the occupant to get real fresh air. And so that this is also part of what's done here in the construction. And here you see other views of the building under construction and the view of a building nearby, in this case steel frame, under construction simultaneously. Of course, all of this is before the crash of 2007, 2008. This is Chicago from Google Earth. You're now experts on the city. You know this is the main branch of the river. Here's the north branch, the south branch. Here's that great park we've been talking about earlier today. Grant Park with the big fountain, the Art Institute here, the Plenza, the Kapoor, the Gehry. Jeannie Gang's building is here. The building, the Spertus Museum building that we just looked at is here. A series of museums are here, a planetarium, an aquarium, a natural history museum. This is the American football stadium in Chicago, Soldier Field. And I think even here you can see, because of the shadows, the height of the buildings here is pretty great. But even just west of the loop, the buildings are much, much lower. So this is a key way in which Chicago is dramatically different than Sao Paulo. Someone asked me earlier, someone calculated a few years ago the average height of buildings in Chicago, and the average height of buildings in Chicago is 2.5 stories, or 25 feet, or 8 meters. And so we have buildings of about 500 meters in height, but the average height of all the buildings is only about 8 meters. So I think Chicago in many ways is probably cumulatively a much flatter city, and it probably also, we're not only half your population, but I think the area we cover is probably as great as yours, so that means our density is significantly less than yours as well. So the Spertus Museum project was here, Jeannie Gang's project is here, and the third building I want to talk about is here. This is Lake Point Tower. So the first building is a representational building. It's for a museum. Representational buildings tend to cost more. But the second and third building I'm talking about today are not representational. They're residential. They are usually they're imagined to be background buildings. And even though Jeannie Gang's building was placed in the midst of development of many other buildings, it has become a foreground building, right? Which is an important thing. And the last building now I want to show you this today is this one, Lake Point Tower. Now, a couple of years ago with a colleague, I wrote a book about Lake Point Tower, and there's a copy in your library, so you can go and see it. And at that time, when my co-author and I began the project, George Schipporeit, one of the architects, was still alive. Alfred Caldwell, at the very beginning, was still alive. And William Hartnett was still alive. In the few years since then, all of them have died. And so we spoke to many of the principals at a time when they were still alive and could tell us about the particular decisions that were involved. And it's, I think, important to understand that there are the architects. I mean, so far I've just been talking about the principal design architects when I've talked about buildings. But here, let's lay out in a little bit more detail, because this is important. The landscape architect is a former colleague of mine at IIT, a distinguished landscape architect named Alfred Caldwell. The structural engineer was William Schmidt. He was trained in Germany and then moved to the United States. And I think as here, much of the skill in Sao Paulo has migrated to Sao Paulo. There has been an intellectual and technical transfer of skill and capability from around the world to here as people migrate. And that's still the case in Chicago, whether it's William Schmidt or Mies van der Rohe or many other architects who moved to Chicago. And the developers, neither of whom came from Chicago either, were William Hartnett and Charles Shaw. And you'll see this in a little bit, but what's important is Schipporeit and Heinrich were not yet 30 when they got the commission for this building. That's an extremely young age to be doing independent buildings. It's certainly an extremely young age to be doing a 70-story building. The developers were in their early 30s. Again, an extremely young age to do a project of this size. And so the benefit here is they were at exactly that crossing point when they know all of the issues that they need to be expert in to solve the problem, but they're still young enough to be ambitious enough that they think they can pull it off. As you get a little bit older, you become fearful of making a mistake. These were guys at the beginnings of their careers who had the skills. They weren't acting above their preparation. They had the skills and were also young enough and ambitious enough, and occasionally they would say foolhardy enough to do something that many other people have said, well, that's too hard, don't you try to do that. So the building itself is striking. It is, because of the change in the lakefront ordinance, the building is to the east of Lakeshore Drive. In the future, supposedly, no other building will be able to occupy this prominent a site. So it is unlike the first two buildings I've shown you, which the Spertus is part of an ensemble. Aqua is part of a dense cluster of towers. This building was conceived as an independent project, or was realized as an independent project, and then I'll show you its impact over time. And as other buildings, in different times of year and different kinds of weathers, it reads in different kinds of ways. You can see it here separated from the buildings that are around it, or close up with the garden at its base and then the tower rising above it. And here's one of the key things about the building. Most tall buildings, as you know, have parking usually underground. And the cuts here in Sao Paulo to get into the base of a building are significant. And what the architects were doing is, because they're at the lakefront, it would have been very expensive both to excavate, to bury the garage underground, and it would have been very expensive to then waterproof the walls to keep the water from coming in. So the decision was made that the parking garage would rest essentially at grade, which means the building is 3 stories. This is about 30 feet. The top level here is about 30 feet above the surrounding grade. Now, this makes it a little bit suburban. It closes itself off from the city around. The people who live here have this lovely park designed by Alfred Caldwell, but they never see anyone around them. It's not like the public park that's just over here along the lakefront, in which you see everybody in the city, not just the rich people who live in this building. So there are some issues, but that means it was much cheaper to build the garage here, and they designed the roof of the garage so that even though there is a pool, a swimming pool, this is an opening to below, on the site, and all of these trees and plantings, there has been never any problem of water penetration through the barrier between the roof of the garage and the plantings up above it. And so then standing on this is an elevated tower with then 70 stories of apartments above it. This is a view from the tower at about the time it was topped out. And I've mostly been showing you images of Chicago as this magnificent place. But this was the site condition when they began the project. There's one other apartment building there. Jeannie's apartment that we've talked about would be about here. Here's the Art Institute way over here. The Gary Bandshell is here. The Kapoor and the Plenza are there. All of this was a below-grade surface parking lot for automobiles or railroad yards for the railroads. There used to be, this was at the time when many grain elevators had been taken away. Now, all of this was imagined in the Burnham Plan as a public park and beneficial development. But there were 100 years of use as railroad lands with a parking slip, factories here, storage facilities here, other storage facilities here. All of this was still in place in the early 1960s when this project began to move ahead. The company that controlled all of this land decided it's probably not a good idea to continue to have this kind of use on land that is this prominent with this accessibility to the lakefront. We could redevelop the site and make more money. And so they took the site here, that's just about here, where Lake Point Tower is, and said, anybody want to build here? And these crazy young guys I just mentioned, Hartnett and Shaw and Schipporeit-Heinrich, said, we'll do it, we'll take a chance. And it took them a while to get all the money. It took them a while to resolve the design. It took them a while to make everything work, which is okay. That sometimes the more time you have, the better you can make the solution. So it took them a while, but then they pulled it off. And over time, I mean, here's Lake Point Tower on this model that I've shown you before. Then all that industrial site you see here has then been redeveloped into a significant high-rise community. So it begins, this is a kind of visionary project that begins the first act that then starts to transform the neighborhood around it. Here's a view. Oh, the river is still polluted. Having the lake and the river, that's a good question. Having the lake and the river means two things. Because the river could be used as a harbor and as a sewer, it meant that the lake could be used as a recreational resource and the source of our drinking water. So we have kept the lake pretty clean. There is a lock here, like on a canal, to prevent the lake water from coming into, to prevent actually the river from flowing into the lake. Because the land is so flat here, we have reversed the flow of the river. So now this water doesn't flow into the lake, it flows in the other direction and then out through the Mississippi at New Orleans. And we put our sewage here and let St. Louis and New Orleans and Memphis worry about the environmental damage. And then we keep the lake nice and clean for ourselves here. Right? St. Louis tried to stop us in 1899. This was going ahead. And the people in St. Louis went to the United States Supreme Court to say, stop, 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 you can't do this. And the people in Chicago knew that they probably shouldn't do this. And so they simply opened up the valves and started to let the sewage flow towards St. Louis. And when the court actually took up the case, they said the English word is moot. Well, since the damage has already been initiated, there's nothing we can do to stop the damage from continuing. So this is the circumstance of Chicago every day commits a great wrong by sending its sewage, some of which is not quite as polluted as it used to be, but it's still our waste. We send it into the Mississippi so that we can keep the Great Lake relatively pure and clean. So you want to go fishing here, you can eat you want to go fishing here, you want to go swimming here. If you catch a fish here, you can eat it and not become sick. But if you caught a fish here, you wouldn't want to eat it. And you certainly wouldn't want to go swimming. But then further, here you can see the tower, and you can see the construction crane in place. The tower is very much independent from all of the potential development here in the future. I should say, too, this is now was a commercial pier. It's now been converted into an entertainment complex. And the large object you see here out in the lake is the water treatment plant for the city. And because it's the treatment plant for the whole city, it's very, very large. At the time this project was nearing completion, at about the time this photograph was taken in 1968, there was an exhibition of Mies's work at the Art Institute of Chicago. And this is a photograph of the installation. And in that installation is Mies's brick country house, which I'm sure you know, his Barcelona chair, the Barcelona pavilion is back here. And here is the Friedrichstrasse skyscraper of Mies. And here is the lobed skyscraper for another site farther south on Friedrichstrasse, if it had a site. And some people have thought that this building, the kind of curving facade of this building, was an influence for the architects. The architects deny this. They say that the solution came out of the kind of design and planning, rational design and planning, that they learned in Mies's school, rather than that they were simply saying, oh, I like this form, I'll try and make it work as a building. And when that exhibition was up, in 1968, let's see, none of you are old enough to remember, I think. 1968, there was an American political convention in Chicago. Hubert Humphrey was nominated to be president, and it was during the Vietnam War, which was immensely disagreed with by especially people who were young at the time. They didn't want to go and fight a war against people who'd done them no wrong. And there were significant demonstrations in 1968. Effectively, the police rioted and beat up a lot of citizens. But in any case, that was a very key moment of crisis and confrontation in Chicago. But because there was the Mies exhibition and there was going to be the convention, two reporters for the New York Times came to Chicago to sort of get a sense of what it was. And both of them talked about Chicago as a place that liked architecture, a place that did architecture very well. And both of them, the architecture critic of the New York Times, Ada Louise Huxtable, and was a political writer for the New York Times, a man named Anthony Lucas, both of them very distinguished journalists. Both of them talked about this building as being under construction, nearly completed, and the best current example of how Chicago continued to build the best architecture in the world. Well, of course, everybody in Chicago said, exactly right, we're proud of ourselves, this is the way it should be. But it was also very nice to have that kind of confirmation coming from writers from someplace else. Now, here's a photograph of the team that put this together. This is George Schipporeit. He was a colleague of mine at IIT. He was dean for a while. This is John Heinrich, so these are the two architects who, and I've always thought that in this photograph, George doesn't look to be about 30, he looks to be about 15. I think he's the president of the high school student council, something like that. I mean, they're both very, very young. This is a member of, these two gentlemen are part of the local bank that's going to be funding the project. And this gentleman is William Hartnett, who's one of the developers. So this is just about the time that they have put all of the pieces together that they can actually, the financing pieces, so they can actually start construction on the site. And obviously, this is a staged photograph. The expertise that John and George, Paul and Ringo, right? John and George brought to the project was John had worked for a residential high-rise construction company. He was trained as an architect at IIT. He'd worked for this company, so he knew very much about building production. He understood it. It was deep in his bones. He got that. George had, from a very early, George had been at school at IIT, and because he drew so well, that is to say, because he designed so well, he was hired at IIT. He was hired by Mies to work in Mies's office when he was still an undergraduate at IIT. So both of them had skills, George in the design end of Mies's office, John in the production end. And the construction the company that John worked for, the contract that he worked for, usually did Mies's residential buildings. So they weren't sort of in the neighborhood, they were very, very close. The landscape architect is Alfred Caldwell, and here you see him sitting in his own house, a house he built by himself with his own hands. So all of these rocks that you see on the fireplace behind him are rocks that he assembled and brought to the house and then constructed. The developers understood that part of the success of a work of architecture was being wired properly with the political forces. And so at the groundbreaking, the figures are, this is Mr. Hartnett, this is Mr. Shaw. These two young men are the two sons of George Schipporeit and John Heinrich. We've always thought that this man represented the mob. In much of America, organized crime has a very powerful hand in the construction trades. There's a priest here, playing benefit, and the mayor of Chicago has come to break ground for the beginning of the construction of an apartment building. Right? I mean, mayors don't usually go and show up for something of this kind of stature, but Hartnett understood that if you get the mayor on your side, so very early on, he went to see the mayor. He wangled an appointment, and the mayor said to him, if you guys can pull it off, I won't get in your way. So that meant that nobody in the city, Daley, the mayor, was extremely powerful. I think that what Jaime Lerner in Curitiba is probably an equivalent political figure who really controls his city. Well, Daley controlled Chicago in that kind of way. So they got Daley on their side. They were able to pull together the financing, and then the building was able to go forward. And it is at the same time they are breaking ground and starting to build the building, they also have to sell the building. And so this reasonable rendering of the building with the tall buildings of the city beyond, but none of that industrial landscape that I showed you a minute ago, which was the actual site. They've sort of compressed, flattened the depth of field on their image, and they claim it's very likely, that's the weasel words that the lawyers always tell you, very likely or probably, the finest apartments, not in Chicago, in the world, right? So let's go for the top. Let's really sort of lay it out there and claim it to be really terrific. Now, as I showed you before, the site had been 18 feet underwater in 1870, but the land had been extended. This is now the current shoreline. The land had been extended so you could build on it, but you were close, but the water was very close by. And as they began to work on the project, they explored not just one, but 3 towers. We can get money for one, maybe we can get money for several. And so this was one of the things, so their ambition was significant. And here's the site plan for the 3 towers. North is at the top. This is the site of the building that was completed, and then they thought they would build the other 2 towers to the south. I don't think that this is that effective as a site plan. I think it's lucky for us that they didn't get to build it. If you compare this site plan as a development to the site plan for Mies's Lakeshore Drive apartment buildings, you can see the difference. Mies knew how to put 2 forms together extremely well. These guys were a little too early in their career to understand that aspect of urban design. But here's their building, just about the time it's completed and occupied. And here's the John Hancock Tower, which this building was at the time the world's tallest reinforced concrete building. And at 70 stories, it was the world's tallest apartment building, exclusively apartment building. Both of those records, this is from about 1970, both of those records have long since been surpassed by many buildings in Chicago. The Hancock Tower is a little bit over 1,000 feet. It's 1,150, which is to say nearly 375 meters, something like that. So pretty tall. And it's a steel frame building. And the 2 buildings you see here, and then not only did the site in this direction from Lake Point Tower get redeveloped, but here now is a view from Lake Point Tower to the Hancock. And all of this, virtually all of this, is new building since the time those buildings went up. So that establishing a vision, establishing a possibility, then in many cases can influence future development. And this gives me a good place to point out. Chicago has this long wall of tall buildings that face the lake. Facing the lake is a really nice thing. And so you can get premium prices and rents for buildings that face the lake. Mies's Lakeshore Drive apartments are here in this photograph. But behind that wall of very tall buildings, just behind it, are some 3- and 5-story apartment buildings, like another about as thick as this zone here. It's basically 1 or 2 buildings thick, and then some lower buildings behind it. And then behind that, it's the vast flatness of this very low city, a city made up of houses not unlike the ones of my house that I showed you a little while in the first talk, the little red house with the snow in the front yard. That's the actual height of most buildings in Chicago. And here's another way of characterizing what's going on. In the silhouette, Lake Point Tower is here, and this is the silhouette of the lakefront at the time Lake Point Tower was constructed. And then in black is the silhouette of the city that has been constructed in those 45 years since Lake Point Tower was completed. I'm using 1970 as the completion date for Lake Point Tower as a round number. So that we're about 45 years from that. And the city has grown very significantly since then. And here are those 2 comparative images down here. The photograph here, it's mushy because it's a photograph of a model of an early version of the tower, photographed not against Chicago, but against the New York skyline. When the project first came into the team of Schipporeit-Heinrich, Schipporeit was working as a consultant in New York City, which is where he first met the developers. And so he then starts to make a paper model, and then they set it up across the East River in Queens so they could get a sense of what their tall building would be like against a sea of tall buildings, such as in New York, or such as in Manhattan. And that building was not the 3-lobed building that I've been showing you, but a building of 4 lobes. And so at the center was a large square containing the elevators for the building. Then projecting from the center were a series of relatively short corridors leading to the apartments. Part of the analysis, and then at the end of each corridor was the fire stair, the emergency stair in case of fire, right? Which is required by law. And one of the things also that became apparent is that residents of very tall buildings do not like corridors that are very long. So by they could have built a very long slab of a building, for instance, and gotten the similar density. But by having relatively short corridors with essentially, let's see, 1, 2, 3, 4, 5, 6, 7, 8 apartments on each lobe, they would then make the walk from the elevator to the apartment shorter, and that was seen to be a virtue. Now, one of the weaknesses of this plan is that it meant that someone in this apartment would have a view into someone in this apartment. And as you know, if you live in a tall building, in a city of tall buildings, everybody is, in the evening when the lights are on in the interiors, everyone is visible to everyone else. I'm sure many of you know where all of the best telescopes are in Sao Paulo, as people like to look at other people in Sao Paulo. This is a standard thing. And there are people who like to perform in their apartments for the people they assume are looking for them. I mean, this is certainly part of city life. But most people, although this is true of many people, most people would say that they treasure their privacy. They don't see themselves as performing for others. And so this became a kind of a potential issue that they were concerned about. But bless you, but they made a model of this, and they had an earlier system of getting into a building, which then was resolved. They made a model of it, as you can see here. They thought it would happen, and they were continuing to work on raising funding. And here you can see the model facing the park. But one of the things that they began to realize is that by having the model such as they did, that meant this became much more axial and controlling and hierarchical than they really wanted. I mean, one of the principles of the modern architecture these architects were working with was that architecture should not be hierarchical. It should be, the organization should be more pictorial than, or picturesque rather than tightly organized. So there was a concern about that. There was a concern about someone here wanting to go into the park, that if automobiles were constantly circulating here, that would make this a less attractive amenity than otherwise. So they began to reimagine that. And then they began to study it. And there were about, in each of these lobes at 70 stories, about 300 apartments. So 3, 6, 9, 1,200 apartments. One of the people who was in charge of money said, that's going to be very hard to market 1,200 apartments. We could do 900 apartments. Why don't we just cut off one of the lobes? Then we have 900 apartments. That we think we could build, that we think we could sell, that we think we could finance. So that's what happens. They lop off the lobe. Their initial exploration when they did that was, first of all, you don't have a person from this apartment seeing a person in this apartment. The more gentle curve here meant that people here and here barely could see one another, right? It was difficult. But all of them had really good views out over the lake or to the city. They still oriented it in this direction, but then they did something which turns out to have been quite smart. They rotated the building, let's see, that's 60 degrees? No, you help me, right? 60 degrees. They rotated the building 60 degrees so that the relationship of this elevation to the park was more informal, less structured, less hierarchical. It meant that they could get rid of the ramp up and down into the building. They could instead enter at grade, go around a circular drive to enter the lobby then placed here, and then you could continue around the circular drive and go into the garage or come in and go directly to the garage. They could open this up so there is a view from below of, and I'll show you that in a few minutes, of the tower looming up above you, which is a very powerful image. So a number of issues, how you deal with the car was resolved, how you formally relate this to the park was resolved, how you go from 1200 to 900 was resolved, right? So this is another one of those examples where a series of good reasons or continuing a deeper analysis of the problem then yields a solution that speaks to the real reasons that are involved here. The language that George Schipporeit used in describing the tower is he compared it to Brancusi's infinite column, which most of you, but if you don't know it, ask Fernando and he'll show you, or Alvaro is seated behind the column. It's a very important, and this was a great piece of modern art that Schipporeit knew, respected, understood, and was thinking about as he worked on this project. So that means that the column structure, the elevator core becomes a triangle. Right? It means that there was one row of perimeter columns here adjacent to the curtain wall, and then only 4 structural columns here in each of the bays, which were close to the corridor, and so they could develop this as essentially service, bathrooms, kitchens, that kind of thing, in the apartments, and then preserve this very large area of open space, or essentially open or universal space, looking out over the lake. So once again, you see a whole series of problems are being resolved as the design development moves forward. And you either already, well, now most of you are architects in practice, is that my understanding? Is that correct? So you already know that this is a way that work in your office takes place. You may not be working on a 70-story building, but you know that there are a whole series of early steps in a project, and then there is this realization and this continuing exploration that then leads to a solution that people become pleased about. And so from that kind of large scale or more open thing, this is then how that begins to work out. All of the services can be then placed within and around the interior columns, yielding this very large amount of open space here. It means that the columns that back up against the triangular wall, or the apartments that back up against the elevators, have the advantage of fabulous views straight out, but they also have a slightly irregular shape, a slightly irregular way of accessing the space, but it's not the end of the world, and so that's 2, 4, 6 apartments on a floor have certain issues with space planning, with angled walls, and that sort of thing. But it means also that 1, 2, 3, 4 apartments in each lobe, which is 4 times 3 is 12. So 1/3 of the apartments are challenges for interior design. 2/3 of the apartment are slam dunks for the interior design. So this also is a benefit as they begin to work out the project. And because of the structure's character, you can go from having fairly small apartments, 1-bedroom apartments, or even studios, to many bedrooms, 3 and sometimes, and subsequently Some people have bought more than one apartment, and so they have then been able to have a very large space for themselves. As you can see from the exterior, this is a building with a curtain wall, and the curtain wall is a very sophisticated, it was at the time at the absolute cutting edge of curtain wall design. This is the first large-scale apartment building that had double glazed glass. The outer sheet was bronze tinted to reflect solar gain. The inner sheet was clear glass. So that is very sophisticated and up to date. They terminated the floor plate here, and then through a series of connections here, had both a secure connection for the curtain wall, but also had very close to a complete thermal break between the solar gain or the winter cold from the curtain wall, conveying that into the interior of the building. And in a place like Chicago where it gets warmer than it is now in the summer and infinitely colder than the coldest day you've ever experienced in the winter, when you've got that dynamic range of temperatures, that it matters at all seasons of the year. There is a requirement for natural ventilation. So there were hopper windows down at this level, at the lower level. There was a continuous bench at this level running around the interior of the space. And where it was open, there was a plastic grill that then allowed fresh air to come in. There was also, though, for each volume, each separate volume, a living room or a bedroom on the perimeter of the building, there was a through-wall heating and cooling system that was electric, that was designed, that was just coming on the market. It was controlled individually in each apartment. Now, this isn't an issue here. I mean, most buildings in Sao Paulo don't have heat, and most buildings in Sao Paulo don't have air conditioning, right? Yeah. So that's not an issue for you. The temperature's always okay. In Chicago, where it's either too hot or too cold, it's almost all the time that you need to heat or cool the space, or at least have an air exchange so the interior is comfortable. There's no, I'm sure you've noticed, there's no cross ventilation here. So this new heating and ventilating system was absolutely up to date. This is the first building in the world in which this system was exploited and employed. So we're looking at people at the leading edge. Because it was at the leading edge, the General Electric Company, the people who made these systems, became investors in the building. So this is an example of how all of that begins to work together. The building also has a very sophisticated structural system. It is absolutely up to date. It would be, I think, too much to say that it was an innovative structural system. I mean, most everything that was used here was already established and was known. But it was done in an extremely well-informed and successful manner. Because the building is so tall, they had to go very far down. They went down about 90 feet below grade. And they didn't actually touch bedrock. They touched what we call hard pan, which is a kind of clay that is, because there's 90 feet of earth on top of it, the clay has been crushed together, has been compressed so heavily that it behaves effectively like stone. And I don't know if that's some... And because it's resting on this hard plan, not stone, they then had these very large caisson bells at the bottom so they could spread as much load over as large a surface as possible. Then these very deep, these very substantial columns of 7 and 9 feet in diameter, depending on where they were. Then this large grade beam, just under grade, this beam to take all of the load of the building. And you're saying, well, that's a triangular form. That's the elevator. Yup. The building is is essentially a heavily reinforced elevator core, that triangular core, that rests on the grade beam that is carried by these columns going 90 feet underground with these great bells. They brought miners, people whose ordinary business was mining coal or salt way below the earth, to go down. After they drilled for here, then they had to excavate the for the caissons down below, and they brought in special people who ordinarily didn't do this kind of work to build these caissons at the very bottom, then poured slowly and carefully over time to get up to the grade beam. So that means that the building is all of the load and all of the wind resistance is transferred to and carried by that central column, right? That's what takes up all the transverse loading and conveys that loading as a compressive element down into the ground. It means that the curtain wall, the purpose of the curtain wall and the floor slabs, which were relatively thin, because again, an innovation that was, I'm sure, let's see, have you yet seen the curve of high strength concrete, of the PSI of high strength? Okay, you know that in about 1950, high strength concrete was not very strong, and then it begins to make this dramatic rise. Well, by 1970, the concrete was pretty strong, but not as strong as it is today. Nonetheless, they were able to use the newest material at the time to then create this great resistant element up to about the 60th floor. I think 59 is actually. And then above that, it then becomes a series of columns because you don't need the mass. The structure here in the top about 20 floors could be much less, or about 11, could be much less robust than below because the load that it was receiving was much less significant. And all of that load was transferred then to the core from the outer curtain wall through the floor slabs, and that all of that wind load was conducted through it, and the relatively light dead load of the apartments and the floors themselves were then picked up and carried up to the ground. Were then carried to the ground by this set of columns. But these guys are doing some wind resistance, but mostly they're just carrying the load straight down. And all of that vertical cantilever is, all of those forces, those transverse wind forces, are being conveyed toward the center, and then that load is then converted and sent to the ground. And as you probably know, the triangle is a very, very, very stable form. So we're looking at people who are exploiting well-known concepts of structural engineering, foundation planning, and all the rest of it, and taking advantage of it. That's why I keep emphasizing that this is a building that's absolutely up to date. It's absolutely exploitative of the most sophisticated, well-understood, well-practiced techniques that were available at the moment. Oh, I'm sorry, I'm going the wrong way. And as a way of kind of checking this and seeing, well, is this really true? I mean, this was the understanding that we did. We asked a structural engineering firm in Chicago to do a modern computer modeling of the structural system. Because in 1965, when William Schmidt designed this structural system, this is still slide rules. I mean, this is even before calculators. This is still slide rules and traditional methods of calculation. Now it's possible to calculate the loads of the buildings with a computer to a much higher degree of certitude. And what the engineers discovered is this is a really smart building. This would be a smart and effective solution done today. Its mass could be a little bit less because today's concretes are even stronger, but still this is a very, very effective solution. And you'll find a complete discussion of this in the book about Lake Point Tower that's up in the library for those of you who want to pursue it, who actually have done these calculations yourself and want to check it out. So from that round hole that was opened up at the base, the view up to the tower is quite powerful. I mean, all of these details Jeannie looking at the exterior of the building, Krueck and Sexton looking at the way the planes took the light. All of that then begins to pay off in a building that reads in this way. And one of the things that means is the HVAC system and the little hopper windows are thin enough that as you look at the building, this seems to be the floor plate, not actually as thick as the element that contains the HVAC system, the venting, and the windows. So it's very simple layering seems clearer, and that means that there is the horizontal element and the vertical element, those two across 70 stories. There are not many different things. Because of the curve of the building, the same elements could be used at any place on the building, and as it was being constructed, 2 tradesmen came every day. It must have been a little bit boring, but as soon as they could get onto a floor and install the curtain wall system, all of the elements were small enough and light enough that only 2 men could handle every single element. And so they could simply clip the curtain wall into place. You know, they do a day, they do another day, they do another day. Over time, they did the entire building. So this is another one of the ways in which the efficiencies of the plan were worked out. I want to now bring you down to the ground and show you Caldwell's garden in a little bit more detail. As I finish up, this is the last section of the talk and today. Here's the footprint of the building. This is a drawing by, as I say, by Alfred Caldwell. Caldwell studied briefly with Frank Lloyd Wright at Taliesin. He studied more extensively at IIT with both Ludwig Hilbersheimer, the city planner, and with Mies, and then he Caldwell joined Mies and Hilbersheimer in teaching at IIT. So his influence in the school was significant. He had also been trained by another very well-regarded American landscape architect named Jens Jensen. So he has experience in training in many people. He was part of that community of landscape architects who like to use native materials rather than use exotic materials brought from someplace else. And he exploited this very well. And he also, and I don't know if this is because he also drew very beautifully. And he was the one who recommended that George Schipporeit be hired by Mies in Mies's office because he drew so well. And Caldwell also drew extraordinarily well. And so if Caldwell thought Schipporeit drew well, you knew that was the case. And Caldwell drew not with lines, but with points. So he would make a line of points, and he understood line weight absolutely. So the reason this might look a little bit fuzzy is you're not looking at a bunch of little lines or squiggles. You're looking at someone so in control of his pen that he's making point after point after point after point. And that's why even the plan of the building looks a little bit fuzzy, because it's not some line that's concerned about line weight. It's this series of points throughout the building. And it's the drawings themselves are extraordinarily beautiful. They've been published, and you should see them. But in addition, he's then creating this landscape. Here's the tower. Here's a play area. Here's the inner drive. This and the pool are a play area for children. And then, as you can see in the drawing, the elements here get thicker. The density here is higher, and then it thins out in this direction. So as you move into this grove of trees, you then, as you come back, you have the feeling that Caldwell liked to say, moving into the clearing. That the idea is you would go through some dense forested or planted zone and then move into a clear open space, a clearing. And so that the experience of the pathways, here you can see a little bit of a curve of one, would lead you around and then into an open space such as this, into the clearing, and then have this kind of revelatory experience of a more or less natural landscape on the top of a parking garage in the middle of a big city. And the planting, and here's that large pool raised up, and then the plantings around it. And at the back of it, because what Caldwell also tried to do is recreate the sense of the prairie of the Middle West, so that you could, the stone that he uses is the limestone that underlies the Middle West, and that occasionally outcrops. The trees are typical of the Midwest. They're planted in ways that are, in Caldwell's view, typical of the Middle West. And he even has a spring rising out of this part of the site. Here's his drawing of the spring with water flowing over a bridge. These are pavers leading up to the bridge that goes over. And then here's the planting diagram for what he wants to go here. So there is an extraordinary design here. There's also an extraordinary control over an understanding of all the materials that a landscape architect works with. Paving, seeding, plant material, edging, water, filtering the water, all of these kinds of things are aspects of Caldwell's control. And because both Schipporeit and Heinrich had learned so much by being Caldwell's students, they then in turn felt it was a great honor for them to ask their teacher to design the landscape for their building. And here's that little waterfall that leads, this is absolutely artificial, right? It's on a parking garage. But the sense here is that you've come across this piece, and it's possible, right? Sometimes stone can work in tension, and so it's possible to cross the stream and watch the water then flow out into that larger pool. And I'll end with this image of a cartoon that appeared in the Architectural Record, a leading American publication by Alan Dunn, in which living in the curvy building leads the person who walks out of the building to only be able to walk in a curvy kind of way. That the building shapes our lives and how we move through the landscape.